Assalamualaikum and hi again. In this lecture video, you will learn about the chain rule of differentiation. If y is a function f in terms of u and u is a function g in terms of x, then dy dx it is equal to dy over du times du over dx. And if you see here, when we cancel out the term du, then you will get dy over dx, which is equal to the left-hand side of the equation. The process of finding derivative using this definition is called the chain rule. The use of the chain rule enables us to differentiate complicated functions using known derivatives of basic functions that you have looked in previous subtopic. To put this rule into context, let's take a look at some examples. The first example. Find the derivative of y, which is equal to 2 minus 5x power of 9. In previous lecture video, if you have this function where the power here it is equal to 2, then it is possible to expand this part. But in this case, the power is 9, which is not that easy for you to expand this. Therefore, we need a method to do the differentiation. And in this case, we will use the chain rule. So what we will do, we will assume or let u equals to 2 minus 5x. And since u equals to 2 minus 5x, then du dx, it is equal to negative 5. Just now, we have assumed that this is u. Therefore, y is equal to u power of 9. So we have y equals to u power of 9. And this gives dy du, because our function y here is in terms of u, then we will differentiate y with respect to u. Therefore, dy du. So dy du is 9 u power of 8. Remember, the objective is to find dy dx. So dy dx, it is equal to dy du times du dx. Okay, if you see, if we cancel out du, then we will get dy over dx, which is equal to the left-hand side. And our dy du is 9 u power of 8. So 9 u power of 8. And our du dx, it is negative 5. Therefore, we substitute negative 5. And now we will simplify this, which is negative 45 u power of 8, where u, we know that our u is 2 minus 5x. Remember, your final answer for dy dx should be in terms of x. Therefore, we need to substitute the variable u, which is in terms of x. So, negative 45. Our u is 2 minus 5x power of 8. So, this is the answer for our first example. Next, we look at the second example. We need to find the derivative of y, where y it is equal to 1 over 2x squared plus 7 power of 4. And in this case, you have the function y, it is a fraction. Remember, your y that you want to express, the new expression for y should be in a form of the basic functions that you have learned previously. I mean, you must have the function y is in this form. Okay? So now, I'll show you the solution. Okay, we will rewrite y first, where we want it to be as 2x squared plus 7 power of 4. Power of negative 4. Okay. So now what we will do, we will let u equals to 2x squared plus 7. Therefore, du dx, it is equals to 4x. And since this is u, then you will have y equals to u power of negative 4. So y equals to u power of negative 4, where this is in the form of your formula. The basic formula that you have is y equals to x power of n. Okay? Even though this is x in terms of x, this is in terms of u. So what you have to do is just if you have here, when y is equals to x power of n, then you'll have dy dx, it is n times x power of n minus 1. So what you will do for this, you will find dy du, because your y is in terms of u. So dy du, it is equals to negative 4 u power of negative 5. Okay, what's next is we want to find dy dx, where dy dx is dy du. Okay, now we want to use the chain rule times du dx, where dy du is negative 4 times u power of negative 5, and du dx is 4x. So times 4x. So now we will simplify this. So negative 16x u power of negative 5. Remember, our final answer should be in terms of x, but here we still have the variable u, so we need to substitute u with 2x squared plus 7. So this is equal to negative 16x 2x squared plus 7 power of negative 5. And remember, our final answer, we try to avoid negative power. Therefore, we can rewrite this as equal to negative 16x over 2x squared plus 7 power of 5. So this is the final answer for the derivative of y, which is dy dx. The third example, here we have a function involving trigonometry. In particular, we have sine function here. We have sine. So what we will do, okay, you should know that when y is equals to sine power of n, it doesn't matter sine, cosine, or tangent, whatever the hyperbolic function is, then when you have sine n x, you know that you can rewrite it as sine x power of n. Okay, this just a note for you. Alright, so now we go back to the original function here. So what we will do, okay, we will rewrite the function y, where we know that, okay, since we have this, then we know that we can rewrite this as y equals to sine 3x power of 5. So what we will do now is we will assume, we will let u equals to 3x. Therefore, du dx, it is equals to 3. So when this is u, so you'll have sine u, you will have sine u power of 5. It's sine u power of 5. So what we will do now is we will let, we will let v equals to sine u. Okay. So dv du, we will let v. Why is it? Because if you let v equals to sine u, when v is equals to sine u, here we have sine u, so that means all this is v, so v power of 5. Okay. So dv du is cos u. Okay, remember just now when sine u power of 5, that means you have here v power of 5. So y is equal to v power of 5. So y equals to v power of 5. And since we have here y in terms of v, then we will differentiate y with respect to v. So we want to find dy dv first, where dy dv is 5v power of 4. So what you will have now, you want to find, remember we want to find dy dx, where dy dx is dy dv times dv du. Okay, we want to use all this, dy dv, dv du, and du dx. So we will combine these three terms so that we will get dy dx. So dy dv times dv du times du dx. If you see here, if we cancel out dv dv, du du, then you will get dy dx, which is equal to the left hand side. So dy dv, we know that dy dv is 5v power of 4. So 5v power of 4. And then we have dv du is cos u. So cos u. And du dx is 3. So times 3. Cos u times 3. Okay, we will simplify this first. 15 v power of 4 cos u. Where this is equal to, okay, our v just now, it is equal to sine u. So we will substitute sine u. 15 sine u power of 4. And then we have cos u. Where this is equal to, okay, remember our final answer, because the original function y, it is in terms of x. Therefore, your final answer for dy dx must be also in terms of x. So now we have our solution at this stage is in terms of u. So we will need to substitute u with 3x. Therefore, 15 sine. Remember, we have, whenever you have this, which is this one, then you can rewrite it as this. Therefore, we can rewrite this as sine power of 4u, okay, where u is 3x cos 3x. Okay, now everything is in terms of x. Therefore, this is the final answer. fourth example. Okay, how to find the solution? Okay, first of all, we know that y it is equals to ln root 2x plus 1. Where in mathematics, we know that this can be rewritten as ln 2x plus 1 power of 1 over 2. And the property of natural logarithm, whenever you have y it is equals to ln, let's say you have ln x power of n, you can rewrite this as n times ln x. Okay, this is actually one of the properties of natural logarithm. Okay, therefore this one we can rewrite it as 1 over 2 ln 2x plus 1. So what we will do next is we will assume, remember we try to use the chain rule here. Therefore, we will let u equals to 2x plus 1. This is u. Okay. So u is, 2x plus 1. Then du dx, it is equals to 2. Since we have assumed that u is equals to 2x plus 1, then y is 1 over 2 ln u. Okay. So again, I repeat, because we have u is equals to 2x plus 1, then here we have u. So since we assume that this is u, then you have y, it is equals to 1 over 2 ln u. So y, it is equals to 1 over 2 ln u. And you know that when you have y equals to ln x, where this is, I'm talking about the basic function of differentiation. I'm talking about differentiation of basic function. When you have y equals to ln x, then you know that dy dx is 1 over x. Okay. Therefore, dy du, okay, here we have dy over du. Okay, u here because our function y is in terms of u. So dy du is 1 over 2. Okay, when we differentiate ln, okay, now you substitute it. This is u. So when you have ln u, then dy du is 1 over u. So here times 1 over u, which is 1 over 2u. And our objective is to find dy dx, where dy dx is dy du times du dx, where dy du is 1 over 2u and our du dx is 2. So times 2. And here we can cancel out 2. Therefore, what's left is 1 over u. And we know that u, it is equals to 2x plus 1. Therefore, we will substitute u with 2x plus 1. Thus, you'll have 1 over 2x plus 1. So this is our final answer for the fourth example. Okay, so that's all for this lecture video. Thank you. Bye-bye.